Hello. Thank you for joining us for our fourth installment of Zeeco's Thought Leadership Forum. Today we're discussing hydrogen fuel and emissions reducing burner technology. We're broadcasting to you live from Zeeco headquarters in beautiful Broken Arrow, Oklahoma, as well as our Connecticut office in Plainville and our Zeeco Europe office in Stamford, which is in Rutland in the UK. Today, our experts will explore hydrogen-fired burners, lowering NOx and CO emissions, and the latest advancements in burner technology. As always, these topics were chosen by you, our audience from refineries, chemical plants, and various other industries around the world. We very much appreciate the many excellent questions you submitted to help facilitate today's discussion, and I hope that our analysis will enable you to make more informed decisions as you investigate higher firing concentrations of hydrogen fuel for burners used in process heaters and boilers. It's worth mentioning that hydrogen is part of a broader discussion on sustainability and the technologies necessary for countries and organizations to reach their climate goals. Methane and carbon dioxide emissions monitoring and reduction are significant focuses as well. And we plan to explore these methods and technologies which are available to you for those topics in an upcoming Thought Leadership Forum. If this is of interest to you, I would encourage you to register early by visiting the link on our landing page. If this is your first time joining the Thought Leadership Forum, I'd like to say welcome and thank you for joining us for such an important topic. The goal of our forum series is to answer your burning questions in a more casual and enjoyable environment than the traditional webinar. Please feel free to sit back, relax, and enjoy the content we prepared for you. And I'll start with some introductions. Let me introduce to you our panelists. I'll start by turning it over to Nigel Palfreeman in our Zeeco Europe office. He's someone in our organization that needs no introduction, but if I don't let him speak first, I'll probably never hear the end of it. So go ahead, Nigel, introduce yourself, please.
Hi, everybody, and thank you, Dan, for the kind introduction. My name is Nigel Palfreeman, and I'm the Managing Director of Zeeco Europe and have the responsibility for EMEAR. For Zeeco, I've been here for 18 years, but in the industry over 34 years. I know I can hear you all saying it seems impossible, but that's shocking. Right, 34 years. Shocking, really shocking. I've seen burners develop over the years concerning high efficiency, low excess air, fuel conversions from oil to gas, low emissions with respect to NOx. And I have to say, I'm just as excited about the next challenge, and that's hydrogen fired burners. So thanks for the invite, and I look forward to the discussion. Thank you.
Well, if you know Nigel, that is a surprisingly brief introduction, but I imagine if you've watched the forum's previous editions and have been informed of the time constraints, I'm going to remind Nigel of that, as well as our other panelists here today. And we'll move on to Eric Pratchard. Eric, could you introduce yourself?
Hello, everyone. My name is Eric Pratchard. I'm the General Manager of Zeeco's Global Burner Division. I'll try to be brief and make up for some of Nigel's long-winded response, but I'm a graduate of Oklahoma State University here in the U.S. I've worked for Zeeco about 15 years, working in thermal oxidation and burner technology during that time. Before joining Zeeco, I worked in the aerospace industry, but I'm excited to be here today and look forward to the conversation.
Thank you, Eric. And finally, we have John Gorko. And John, our marketing department warned me that you had prepared a number of slides in PowerPoint for introduction, which thankfully I think we have nixed. But I think that was probably appropriate to convey the extent of your experience. But I hope it'll be more brief for the audience's sake. John, go ahead and introduce yourself.
Yeah, my name is John Gorko. I'm the technical director of the Boiler Burner Group here at Zeeco. We developed the Boiler Burner Group about just over 10 years ago now. So I've been with Zeeco for just over 10 years. Before that, I was with Todd Combustion / John Zink / Hamworthy. And before that, I was getting my master's degree at the University of Connecticut in reactive gas flows in mechanical engineering.
Thank you, John. And with that, I'll just introduce myself. My name is Darton Zink. I also, like Eric, graduated from Oklahoma State University, and I've been here with Zeeco since that time, some 26-ish years ago. And I serve as our president and CEO, a role that I've been in for the last 21 years. And so enough about us. I do want to make one special recognition and introduction. I'll introduce Clint Ellis, who is our technical event manager here at Zeeco. He works behind the scenes to help us navigate the content we prepared today, and he'll try to wrangle us back in if we stray too far off of our desired topics. With that, we'll segue into questions. And so the first question that we received that we're going to address today, and this is admittedly, in my view, a little bit of a softball question, but the question reads, why are we currently seeing higher concentrations of hydrogen being fired? And I will, let's kick that off to John Gorko.
Okay, I think the main reason that we're seeing this increased interest in hydrogen and increased concentrations of hydrogen within the fuels that we're firing is mostly because of the carbon credits and the reduction of tons of CO2. Again, we're trying to go to into green fuels and such. And so as an example, the carbon credits for, I think that are being proposed for the EU are on the order of $50 per ton, and 1 million BTU will create roughly 500 tons of CO2 per year. So that works out to be $26,000 a year. So anytime you could reduce that, it's going to help.
Nigel, you sit in Europe, but what you have a point of view?
Yeah, I'd like to concur with John that the big driving force behind this is carbon credit and CO2 reduction for the environment. Most of the customers within Europe itself are doing lots of feed studies, looking at these programs in general. The idea, obviously, to fire higher hydrogen fuels to reduce the burning of the carbon content and therefore reduction of CO2 overall. And that's really been driven from environmental legislation itself. And it's a hot topic, and why I'm proud to be discussing that today.
I think from my point of view, we see this globally, and there are different drivers. In some cases, we have clients that are looking to achieve their longer-term ESG goals and lowering their carbon emissions. Hydrogen is one way to achieve it. We see this in the Far East, certainly here where I sit in the U.S., Europe, and around the world. The next question is more specific to burners, which is how are burner components affected by firing high hydrogen, and that being burner tiles, gas tips, and the like. And since I skipped Eric, why don't you take the first pass at that one?
Okay, well, thank you, Darton. In all honesty, for a burner that is properly designed, there is no special consideration taking for burner gas tips or burner tiles. The main issue around those components is ensuring that we have separation of the flame from the material and the flame itself. The adiabatic flame temperature of hydrogen is only a few hundred degrees, 500 degrees to be specific,
Yes.
higher than methane. So it's not overly burdensome. The problem is when you have the flame that will actually anchor down onto the burner tip or anchor down onto the tile, and then that heat will degrade that material over time and destroy the product. So it's on us as the burner designer to properly design the burner in that case to prevent that from happening.
And I might say that, here at Zeeco, we deal with, refinery gases that have high hydrogen just about daily. So a lot of our burner designs take that into account already. I have seen other cases on some boilers in my past, shall I say, where the burner design was really set for natural gas. And when they tried to burn hydrogen or something that some other type of fuel like that in it, it did anchor too far back into the burner and pretty much started tearing it up.
I think from my point of view, also anytime you have a pre-mix situation where fuel and air are being pre-mixed, you've got to be extraordinarily careful when converting to a higher hydrogen fuel, just due to flashback. And if you have flashback in the mixer of a burner assembly or even a pilot, it's just a matter of time before the equipment is destroyed and it's inoperable.
I think Eric hit it on the head there, that you talk about the design. I think people's initial reaction is, well, the components, but most of our burners have got components of high grade materials in any way. So, and including the burner tile. So the most important thing is to ensure, as Darren, Eric, and John have said, is to make sure the design of the burner is correct for the high hydrogen firing case.
But John did bring up a very good point, that we have to help educate our customers and our end users on, that the higher the hydrogen concentration becomes over time, when you have an end user or one of our heater customers that requires a pure natural gas startup case in addition to a very high hydrogen concentration fuel to be considered, that makes the design of the burner exceedingly more difficult to make work for both cases, simply because of the difference in volumetric flow between a high hydrogen gas and a natural gas, and the exit velocity from the tip that you must achieve to ensure separation between the flame and the tip. So please consider that when you're looking at these cases. A natural gas startup case is quite common in industry, but as we are progressing to higher levels of hydrogen, some of our customers are beginning to reconsider that case.
All good points and good conversation. I'm going to move this along to our next question, which reads, what is the major challenge or limitation with these burners during startup? And I've got an opinion on this as well, and then I'll ask everybody to weigh in. I would say if you're firing a high hydrogen fuel or 100% hydrogen fuel, and you're talking about lighting up a burner that is already in a furnace that's operational, that's relatively straightforward. Follow the normal startup procedures, pay attention to the gas pressure and startup envelope for the burner, and it's really not that much different than lighting up a burner on a conventional fuel. Where it becomes trickier is when you're starting up a furnace or a boiler itself. We've had questions come in on this specific topic, in which case I'd say that's where you need to pay special attention to valve leakage in your fuel gas system. And once you're reasonably certain your furnace is free of combustible material, lighting up the pilot, proving the pilot using a robust and reliable method. In this case, I'd probably recommend a properly selected flame scanner, and lighting it up. We've had questions also that come in on high hydrogen as a pilot fuel. I don't know of anybody that's using 100% hydrogen as a pilot fuel. A lot of times we've had people talk about lighting pilots on natural gas or a more common fuel, and then bringing the furnace up using that fuel and transitioning to hydrogen. Those are methods that I think sound easier and safer to me than a hypothetical scenario where it's all on high hydrogen or 100% hydrogen fuel. And Eric, you're seeing these kind of questions come in the studies that we're doing. What you weigh in on that?
Yeah, we get asked this question quite a bit, and it really varies from geographic location, and also when you're talking about the difference in operators versus heater designers or packagers. So what I would say is that we're certainly going to follow the recommendations and the standards that are set forth by organizations such as NFPA, EN standards, API standards. Those will help us with defining the safety control systems and the shutdown systems. But when you're talking about the startup of a fire device, of a fire piece of equipment, it is by far the most dangerous point in the operation of that furnace. And ensuring that we have a safe atmosphere to start the furnace will more than likely require a difference in purge time. You know, we all have standards in terms of volume changes in our furnaces for purging. Because of the wide flammability range of hydrogen, that might have to be reanalyzed and increased from the standard. But more than anything, it's how do you start a burner with a visual flame that your operators can see and verify is stable, to ensure that you can continue to bring that heater up in rate in a safe atmosphere. And to be fair, most of the requests that we are getting at this time are still doing it the traditional way, where we're starting up on a different fuel gas. We'll be starting up on a refinery blend that, yes, it will have a concentration of hydrogen included, but it also has a significant amount of hydrocarbon. So the flame is therefore visible, and it's more easily controlled in a safer environment. That's the traditional way, and that's the way that we're continuing to be asked to operate at this time. I'm sure that will change, but that's our current experience.
Yeah, so a lot of the questions, Eric, they get aimed about potentially 100% firing of hydrogen. It'll be interesting to see how the industry goes and to what levels of hydrogen they really do decide to fire on. As you mentioned, there's lots of subjects, whether it's the visibility of the flame, and it also may mean that certain operators look at the way they monitor the flames. So whether they have the visual means or whether they look at adding flame scanners and other types of instrumentation to make sure it's safe when you start firing hydrogen itself.
Yes, I agree.
And I'd say, to me personally, I like the idea of bringing a furnace or a boiler up on a natural gas or a refinery fuel gas or something more traditional, and transitioning to a higher hydrogen fuel or 100% hydrogen firing than starting out that way. Just because there's lots of things that I would say are heightened safety and operational concerns that we just mentioned.
Yeah, the characteristics of hydrogen make it just exceedingly more dangerous in that startup case, as opposed to other fuel gas compositions. And I think our operators and our customers are considering that the majority of the time.
Right. Correct. I mean, having said that, we've done 100% hydrogen pilots. I know John Gorko's done those in boilers. I mean, there's ways to do it, but again, everybody needs to, when we consider those cases, look at it and enter those with our eyes wide open, so to speak.
Okay.
With that, I'll move on to my next question, which is kind of a related question. What's the impact of firing high hydrogen on flame scanners and pilots? And I haven't yet really picked on Nigel yet, so why don't you lead us off with that one?
I appreciate that, Dan. So flame scanners. We're talking here about flame scanners, and we'll talk a little bit about pilots. I think flame scanners is probably the easier one to answer. Most UV scanners over high hydrogen levels within the fuel, so let's say over 80%, do struggle. And so the question is why? Because the water vapor that is produced when you burn the hydrogen with oxygen produces water, and therefore it's water vapor in that temperature zone. So that masks the UV signal on a typical flame scanner. Zeeco have, as I'm sure a lot of you are aware, we have our own ProFlame scanner. which we have fully tested, and it's proven on 100% hydrogen. So the question is, how does it work? So what's different about it? So our ProFlame scanner is focused on the UV emission point at a certain wavelength. So we're focusing on a certain area that we know is going to give us the right signals for 100% hydrogen. So it's designed to capture electromagnetic radiation and thermomagnetic radiation at that correct UV wavelength and at that emission point. And I think that is, as people move into this high hydrogen area, it's going to be vital that you have the right selected flame scanner that is capable of monitoring these high hydrogen levels reliably. If we talk about pilots, like any company, Zeeco has a full range of pilots. We do have 100% hydrogen pilots. A lot of pilots that are currently out there are self-inspirating, so like a premix. So obviously in those cases, it's if you're going to work on higher hydrogen levels, you've got to be aware of flashback. Flashback is where the flame speed exceeds the propagation of the mixture coming out of the pilot itself, and it will flash back and burn back to the nozzle itself. So the speed is faster than the gas mixture. So looking at the design of that, looking at the pilot and making sure that that's correct is important. The other area that people will want to look at is pilots often have ionization detection also. Ionization detection, again, will struggle at very high 100% hydrogen levels. And again, that's due to primarily the water vapor that will be produced in the combustion area itself. So ionization can be a problem, and at that point it may require that the pilots can be looked at with the addition of a flame scanner to monitor the flame of the pilot, and these can often be retrofitted onto the base of the pilot itself on existing pilots, or we do have a range of pilots with the scanners installed. So I think those are the main topics when we talk about flame scanners and pilots with respect to high hydrogen firing.
So Nigel, like a lot of us, has had a lot of experience with startup and troubleshooting, and pilots and flame detection are always sort of troublesome topics, and one for which we're all pretty passionate about. John or Eric, you want to weigh in on this topic at all?
John, go ahead.
I would probably say that my experience with 100% hydrogen pilots is generally on a raw gas pilot, not a premix pilot. That is fairly easily to transition back to a natural gas pilot. The premix, not so much.
Right. I think to the comment I made earlier, whether it's the burner itself or that's premixed, or an aspect of the burner, if you have partial premix or even premix on pilots, all those things that will require special attention during the design process when we're talking about this subject.
Yeah.
Okay, with that, I'll move on to the next question. Which places in our experience or to our knowledge are using hydrogen fuels? Is this pure hydrogen fuel fired heaters or hydrogen fuel blends? And I'll kick that back to John Gorko.
Okay, in my experience, most refineries have been using hydrogen blends with either hydrogen methane or hydrogen methane plus higher hydrocarbons for decades now. There are a lot of places going to higher hydrogen now. Back 20 years ago, 60% was a high hydrogen level. Now you're seeing 85 to 90%. Hydrogen's also kind of on the expensive side, so you generally don't see a lot of places right now where they want to burn full boiler load on a straight hydrogen stream. A lot of times it's still blended with either methane or refinery gas. What we do see a lot of, and this I see a lot globally, is a lot of hydrogen waste streams. And it's usually, those are usually 100% hydrogen or 95% hydrogen with some water in it. And those are generally burned as a secondary fuel, with the main fuel burning all the time. And they're only usually about a partial load of the boiler, like on the order of 30% or roughly. If that makes sense.
Okay. Eric,
Yeah,
anything you want to add?
Yeah, I agree with that. I mean, I see that quite regularly, or we see that quite regularly over all of our product lines, inclusive of process burners for refineries and chemical plants, boilers, or HRSG applications. A lot of our customers have access to 100% hydrogen streams, but they do not have consistent, reliable access to enough hydrogen that will satisfy their full heat load requirements. So we have different varieties. We will have customers that want us to include a tip or a lance or a burner specifically designed to fire 100% hydrogen when they have it available. And then they will have us design other devices for the different refinery gases. Some will blend them together. But I agree with John that the consistency of higher hydrogen concentrations is becoming much more common. I agree that years ago, 40 to 60% was standard. Now we're seeing 75, 85, 90% becoming more of the standard as opposed to the 60. So we know that's where it's going. We're doing R&D testing and development testing of our different products in order to understand better how we can utilize those varying compositions and improve our performance for our customers as well as the safety of the burners. So we're doing everything we can do, or that we know of to do right now, based upon the inquiries and the information that we receive. And if anyone could use Zeeco's help or would like to speak to me or speak to somebody else on our team about a specific application or something that they would like us to look at for them, we'd be happy to do that, because it's what we do. We enjoy it.
We do have applications which are 100% hydrogen, though, which is, those started up in the last couple of years, that are 100% hydrogen, and they take on full boiler load.
Huh. Yeah, good.
So CO2 reduction, as we discussed earlier, is the hot topic generally in Europe and in the Middle East generally. And as you're probably aware, Zeeco are promoting ourselves as H2 ready. So one of the reasons we want to have these kind of informal discussions is to make you all aware of some of the challenges and what can be done. But my experience of this, there is this push generally to go higher and higher for hydrogen. There's lots of studies going on what that might impact. So whether it's the fuel handling systems, whether it's heat flux profiles in the furnace, to understand exactly what the impact will be. A lot of that is generally going on right now. And you know, of course, the drive is fire high hydrogen to reduce the CO2, but also meet the emissions of 100 milligrams generally or lower. So, you know, we have lots of burner applications where we are looking at these requirements, and we've got studies that will be that are ongoing and will continue to go on. So we feel like we've developed and designed our equipment to try and meet the requirements that you have.
And it's a related topic, and I'll be very brief on this one. Related topic, but probably a different conversation. When you're talking about CO2 reduction, it's not only high levels of hydrogen. We're exploring much higher elevated air preheat temperatures than have been traditionally present. Right. Where years ago, 400 degrees Fahrenheit was a traditional preheat number. People are pushing that to 800, 900, 1,000 degrees Fahrenheit of preheated air, firing higher levels of ammonia streams and trying to achieve low NOx as well as low carbon, firing ammonia as the fuel. So it's not only specific to hydrogen. There are many other philosophies and theories about how to continue to supply the heat necessary for our processes while reducing our carbon emissions.
I'd say just from my standpoint, it's a really interesting and I'd argue a really exciting time to be in the combustion technology business, just because there's real meaningful change being studied, contemplated, and investments that are being made. We're doing, as Eric and Nigel alluded to, a number of not just inquiries, but studies and testing in our test facility that are being driven by these directives and this push within the industry. So it's pretty exciting time for us right now.
Yeah.
I will move on to the next question, though, as interesting as that one was, which comes back to a more traditional topic, which is NOx. And the question reads, does more hydrogen content in the fuel gas result in higher NOx emissions? And what would the percent NOx increase on hydrogen firing be compared to natural gas firing in water tube boilers or furnaces? So since boiler was mentioned first, John Gorko, how would you address that question?
Typically what we see in a boiler when we take emissions with 100% methane or natural gas, and then switch that to 100% hydrogen with a conventional low NOx burner, staged fuel, that's generally a factor of 3. So if you're making 50 ppm with natural gas of NOx, you'd make up close to 150 ppm with with hydrogen, sorry. And then with some of the ultra low NOx burners where we're inducing furnace gases into the fuel jets, such as our free jet, that factor goes down to about a factor of 2.5. So it's still significant, and the way that we have dealt with that on a boiler is generally if there's a system that's designed with a flue gas recirculation, FGR, we'll just use more FGR to meet the same NOx as we had with the natural gas. And that may sound a little, costly to do that, but actually, when you look at the lower amount of air that is required for hydrogen burning, it's 560 pounds of air per million BTU, versus for natural gas, it's 723 pounds of air per million BTU. The amount of, if you replace that air that the fan no longer has to push for the hydrogen firing itself, and replace that with FGR, flue gas recirculation, it ends up to be roughly the same furnace temperature or flame temperature at the burner and the same mass flow through the boiler. And so it kind of works out so that it is the exact same NOx, and you can still use the exact same fans.
That's an interesting concept on added FGR displacing air that you're not having to push through the burner as you go up into high hydrogen or 100% hydrogen firing case. From a process burner standpoint, Eric, you have a comment or two on this?
Not too much different, but from a process burner standpoint, we're exploring new designs based upon this push to higher levels of hydrogen. So again, from a traditional ultra low NOx burner, which would be Zeeco's free jet burner, where we introduce the vast majority of the heat release around the outside of the burner tile, we're able to induce a significantly higher amount of flue gas per pound per fuel. So our increase in NOx would be closer to a factor of 2 or less in that case. But we're exploring new designs that we think, and we have shown, will be even less than that. And these are burners such as Zeeco's new Zenith burner, which is an ultra low NOx lean premix burner design. And we found that in excessive lean premix burner designs, the effect of the hydrogen concentration on the fuel is even lower than that. And that's what we're currently exploring with some of our other customers as well.
Okay, good. And I'll just apologize to Nigel and to everyone outside the U.S. for our continued use of terms like pounds and BTUs and degrees Fahrenheit.
Sorry about that.
Please contact any of my colleagues for the appropriate conversions after our discussions today. All right. Next question is, what does firing high hydrogen, what effect or impact does firing high hydrogen have on the fired heater heat flux profile, and how can this be addressed? And what testing has Zeeco done on different types of burners to understand these changes and effects? So that to me sounds like an Eric question. So why don't you take that one?
Okay, and I will apologize in advance because all of the numbers that I have in my head are all in feet and pounds. But in a traditional refinery fired heater, shifting to a higher levels of hydrogen will lower the heat flux profile in the furnace. And that's simply a function of the flame speed of the fuel. So methane, traditional methane, has a flame speed, a laminar flame speed of about 1.3 to 1.7 feet per second, depending upon the resource. Hydrogen is closer to 6 feet per second, 5.6 to 6 feet per second. So you're releasing the same amount of energy much, much faster. And so the heat flux profile drops down inside of the furnace. And what we found is it's roughly equivalent to a raw gas burner from the 1970s and 1980s, when the majority of the heat release happened in the bottom 1/3 of the furnace. As ultra low NOx burners advanced and flame lengths became longer and longer, those heat flux profiles began to move up inside of the furnace, up into the top 2/3 of the furnace. We do have ways to mitigate that. Again, we do that through the induction of flue gas and the leaning out of that hydrogen fuel to try to lengthen the flame and delay that combustion reaction speed. And that's the way that we would do that to try to meet any targets or guidelines that were given from the customer. But it's more difficult in a refinery fired heater as opposed to a heater that would have a radiant target wall, as an example. For a ethylene cracker, as an example, where we would have to meet a heat flux profile from our customer, we have the ability to direct that fuel along that target wall, induce flue gas, delay air mixing in a method that can allow us to more effectively craft that flux profile. Now, we will never be able to duplicate the heat flux profile you can achieve with natural gas with hydrogen. It's the characteristics are just too different. But we do have the ability to come close. And we're consistently working on that in our what's known as our enhanced jet burner, which is a burner we use for our ethylene cracking furnaces, as well as our free jet burners, which we make in both round flame versions for refinery heaters, as well as flat flame versions for cracking furnaces and other types like that.
I'd say if there's an application where there's a flux concern or a critical application, and you're considering a retrofit for higher hydrogen firing, this is a great candidate to do a little upfront study using CFD or some other form of engineering analytic method, and that's something that we routinely provide as a service for some customers, which will start. We're making a change to the process. We're changing the fuel, and to lower the risk that's associated with that process change, a little upfront study oftentimes is a modest but very effective investment in understanding the effect of that process change and making sure that it works to expectations.
Absolutely.
And kind of as I say that, I was going to go on to the next question, but I'm getting the signal from Clint, who's wrangling our event here, and he's giving me the signal that we are now we've reached the end of our time. Please know that if we didn't answer your question today, that our team will reach out and respond to you individually. We did not get to all the questions, but we hope that today's discussion helped give some insight into hydrogen firing in burners for process furnaces and boilers, as well as some thoughts on current solutions that are available to help lower NOx and CO emissions that are associated with this topic. If anyone has additional questions, comments, or feedback for all of us here at Zeeco, please fill out the form that's on the webpage. We also invite you to submit any topics that you would like for our experts to discuss in future editions of our Thought Leadership Forum. In fact, the reason we selected hydrogen today was a suggestion from one of our customers, our customer base. And as I mentioned earlier, we're dedicating an entire forum to the methods and technologies to monitor and reduce methane and carbon dioxide emissions. You can register early for this event and submit your burning questions, like that, burning questions, by visiting the link on our landing page. And with that, I just would close by saying thank you again for joining us today. We hope you enjoyed the event as much as all of us enjoyed being here and delivering it. Please be sure to subscribe to our YouTube channel and follow us on social media, which will help everyone stay up with and up to date with our Thought Leadership Forum series and any other upcoming Zeeco events that we have planned. And so appreciate everyone being here. We look forward to seeing all of you, hopefully in person sometime very soon. Thank you.
Thank you, everybody. Thank you. Thank you.
Give the obligatory hand wave at the end of the video call.
Thank you.
Thanks, everyone.